So we had a nice previous session from Reddit, and we had a nice learning on how convergence can help. And we're going to build on the same, how convergence of different platforms, your different services running on a similar platform can help in compliance projects as well. So we are here today to talk about shift left compliance. It's a topic we lived right for the past few years. Me and Bharath has worked in this space from the last few years. And so we're going to start the presentation now. So this is just a disclaimer, just a quick heads up that we are not advertising any services or any products from third party. We may have some examples about open policy agent or a few examples just to hypothetical, just so that audience can understand it easily. But we are not advertising any product or any specific service. So here is our agenda. I'll start with a problem statement. Then we'll have a fitting compliance in which we'll talk about how organizations used to handle compliance projects. Then we're going to talk about our core of this presentation, shift left compliance and the framework which we are proposing. And then we'll end this talk with outcomes and challenges. Okay, so to start with problem statement. So when we talk about compliance, our minds immediately come to what is compliance? About GDPR, FedRAMP, HIPAA compliance, all these compliance come to our mind, right? So these have been along the gold standard, centering on the pillars of data security, privacy, and risk management. And let's be clear, compliance is not just a checkbox exercise for organizations, which every organization has to do some random compliance just to prevent from legal fines or some sort of legal headaches. It's fundamentally a trust exercise. It's how we prove to our customers and stakeholders that their data is safe in our hands. I believe compliance is very important for each and every organization. However, here is a problem we are facing as an engineer. The landscape is moving faster than our manual processes we can. We are not just looking at the foundational rules anymore. We are now seeing a new wave of specialized high-impact frameworks. So the complexity is exploding. And that's why exactly we need to talk about how can we shift left. And you can imagine with the AI, the complexity is way more. We have another dimension. So we have to recognize this compliance program can be deconstructed into technical requirements that need to be a property of our infrastructure. Ultimately, it boils down to tangible engineering goals, such as automated data residency. As a first one, it means how can we programmatically confirm our data stored to specific jurisdiction. Next one is zero trust access control. How can you enforce your security controls over each microservices? Then the next one is automated data lifecycle and lineage. It means how can you implement programmatic data mapping to track and giving an access to the end user to delete their data to satisfy the privacy requirements. And the last, obviously AI governance and explainability. How can you have a traceability about what your model is providing the output? Suppose your model is giving some output, how can you have a tracking mechanism? Why did this model give this output? So you need to have observability about that as well. In short, compliance needs to be a property of your system, not an afterthought. So when we design the systems, we need to think about compliance. Next, fitting compliance, yeah.
All right. Now that we've seen some examples of regulations and the technical requirements they boil down to, let's talk about how we deal with compliance programs. What does compliance mean for existing systems? The process of changing existing systems to fit new compliance regulations is slow, expensive, and disruptive. In a regular compliance model, an audit of the infrastructure for a new compliance program highlights all the systems that need to be changed. The work is distributed across the organization to the owning teams, or in some cases handled centrally by a focused team. The teams have to plan and update these systems to satisfy the requirements of the new compliance program. As a bonus, all of this work comes with a very tight deadline. These changes are usually not straightforward or low effort. For example, if a new regulation demands data residency, you are required to migrate data from a highly optimized, globally distributed database into a strictly localized database that respects jurisdictions. This is a core design change for any system and requires careful planning and execution. Other examples of work here could be partitioning data processing environments for data residency or changing security access controls for zero trust, like we just heard in the previous talk. But the problems don't end once you've made your existing systems compliant. As systems evolve or change, they could introduce new violations which are only caught later by audit tools, and the teams have to fix these violations in a hurry to keep the system compliant. In other words, existing compliance systems can backslide away from the compliance baseline. Ultimately, what does this cost us? It results in innovation drain. The effort required for compliance diverts significant engineering resources away from new feature development and actively slows down innovation. So what does compliance mean for new systems that we build? Generally, compliance doesn't really affect building new systems, and that is part of the problem. If a newly built system is developed and deployed without upfront compliance considerations, it is likely to violate multiple mandates from day one. Instead of starting with a clean slate, we end up deploying non-compliant systems right from the start. This results in additional work for teams and a perpetual backlog for the organization of non-compliant systems for the organization. As an organization scales and the number of initial violations increase, it becomes increasingly difficult to address this toil in a timely manner. Now, and finally, as the graph shows, the cost of remediation increases the deeper into the software development cycle we attempt the remediation. Finding a compliance violation in early dev is a quick fix. Finding it in production requires a complicated migration process that involves data and traffic. This compounding debt on new systems and backsliding of existing systems is the main focus of our talk. While we can't magically eliminate the need to retrofit existing systems for new regulations, we can fundamentally change our development lifecycle to stop creating new non-compliant systems. So this is where we propose to shift left compliance, which is the title of our talk. It is a fundamental paradigm shift in mindset and development lifecycle with respect to compliance. Instead of treating compliance as an afterthought, we advocate to integrate regulatory requirements into the system from the very beginning of the design and development phase. The concept is very similar to modern security practices. We shouldn't build a system and then think about security later. Security must be intrinsic to the design process. Shift left makes compliance an intrinsic property of the system in the exact same way. Shift left compliance relies on a few key changes to our development cycle. Turn-up integration is the first one. By actively enforcing policies during the initial creation of a system, think of a binary, a database, we ensure that new infrastructure does not result in compliance debt. The second is workflow absorption. Instead of having organization-wide reactive remediation projects, engineers can address compliance mandates in small, manageable increments directly within their standard development workflows. The ultimate goal is to bend the curve on the rising costs of compliance. By addressing regulations early in the development cycle, we transform the unsustainable cost of compliance into a manageable process that significantly reduces long-term engineering costs. So what does shifting left actually mean for us in practice? At its heart, shift left compliance means we integrate compliance requirements into our design and development cycle right from the start. We're taking the compliance checks that traditionally happen at the very end of the line, could be during an audit, could be before a production launch, and pulling them all the way to the beginning of the engineering lifecycle. By doing this, we fundamentally change the nature of the work. Instead of compliance being a roadblock at the end of a project, it becomes part of how we build software. To actually execute this shift and see how it works, we will dive deeper into 4 topics. The first one is compliance as code, where we look into expressing compliance requirements as code. Compliance at turn-up, where we dive into methods to ensure new systems are born compliant. Continuous enforcement, where we will look at using continuous enforcement to prevent backsliding. And then the last part is to automate CI/CD checks, where we will look closer at how compliance checks can be integrated in CI/CD.
So to deep dive into the first one, compliance as a code. Now, to truly shift left, we have to change how we define the rules. We are taking complex, often ambiguous regulatory language, like given by legal team, big PRDs, and we need to translate into machine-readable version control policies. So we're going to call this deterministic translation. Till now, the human being has been translated the big PRDs and your engineering terminologies. What does engineering team need to do? So now we need to bring the human interpretation out of the loop. Obviously, the error is going to come out of the loop too. So a policy shouldn't be a maybe. It's going to be a given binary Boolean, either pass or a fail. So we're going to call that software-driven governance, where policies are treated exactly like our application control, version control, and centrally managed and automatically enforced. And of course, this is not a solo mission for engineering. It requires deep collaboration with our compliance experts to ensure that when we write code, it actually reflects the legal intent. And the beauty of this is it's a unified enforcement. We can use a general purpose engine like a OPA, Open Policy Agent, that can enforce these rules across everything from CI/CD agent, pipelines to different microservices. It's going to propagate automatically to different services. And you know what's a real win? It's a highly scalable. So we don't need to add a support for new regulation like adding a HIPAA or CCPA or different regulations comes next year. We're not going to do that. We're just going to append our policy and it's going to enforce it again. So it's simply a matter of authoring and appending new policies to our existing framework. Next, we have a few examples of Open Policy Agent. I'm going to run through them. So let's look at our first concrete example. We are enforcing a policy that fails any Terraform deployment, like owner, data classification, or cost center are missing. Let me run through the code. So first we are defining the mandatory tags here, like owner, compliance scope, and data classification. And then it performs a set of theory, like it subtracts the tag from the code. If any of the tag is missing, then it gives an error. Hey, you haven't defined your classification properly. So the data classification is, let's say you have a binary or a database, and you need to define what type of data it is. Is it like a metadata? Is it like a PIA data? What type of data are you storing in that binary or Flume job or whatever their asset infrastructure is that? So all in all, there's no ambiguity. Hey, who launched this instance? Why is it non-compliant? Why is your alerting coming up? Why is it? So no more, because you can't have a new asset which will deploy and get failed. Okay, let's look at the next one. This is about the FedRAMP. I'm sure most of you have heard about FedRAMP. In highly compliance environment, simply saying our data is encrypted is not enough in FedRAMP. You need to have a customer manage encrypted key rather than just relying on a cloud provider default settings. So we're looking at some Rego code again here. So you can see we check for configure encryption setting, if you have the encryption setting or not. If there is no encryption setting, it just fails and gives an error. So it returns a specific FedRAMP violation error message here and stops a major compliance incident before even single byte of storage is even provisioned. So we have turned a complex 50-page regulatory requirement given by our legal team into a 10-line logic check. So this is very highly effective because you can't provision a new infrastructure, which is FedRAMP violent. Okay, the last one. Our final OP example demonstrates how we can use dynamic logic to enforce data residency based on data residency. This is quite common, especially when, let's say, you won't have a user in EU region need to store their data in the EU. So we wanted to make sure their personal identification information, which is called PII, need to be in the EU, while other like a logs or metadata or traffic data about them have a global, can we get provisioned into EU, US, EU, Asia, you don't care about that. So we created a map of allowed regions, which are the allowed regions bound to a specific data. You can see PII need to be stored in the Europe West, and public can go anywhere, we don't care. And similarly, when a storage bucket is proposed, the policy extracts two key pieces of metadata, the data classification label and the intended location. It's like a key value pair. Your key value pair matches, it passes, otherwise it just gives a violation. So what's powerful here is that a single centralized Rego file has replaced what we used to be a massive multi-week manual architecture review. So we have automated the where and why of our data storage. Okay, next one is, the second leg of this is compliance at a turn-up. So this is the most critical aspect of this whole framework, compliance at the turn-up. A common fear with the compliance is that it slows down the innovation. Born compliant is our answer to that. We want every new piece of infrastructure to be correct by default. So engineers can focus on features, not flip-flopping through 100 pages of security manuals. So these are 3 ways we are proposing how can your infrastructure is born compliant when you're deploying a new microservice. So first is paving golden path. How do we actually do this without developers slowing down? Because we don't, at this era, we want our developers to be fast. You can have different tools to write the codes. We don't want our developers to move very fast. So we can have a golden paths. Our security and compliance teams had create and thoroughly vet the infrastructure as a code templates. Within these base templates, there are critical settings like specific logging levels are pre-configured to compliant default. Think of it as like a premium starter kit. By using the guarded configuration, we can take the guesswork out of the equation. Next is the guided configuration and the guardrails. So whenever developer goes to spin up a new service, they are met with a guided configuration and restricted choices. We limit their inputs to a pre-approved list of compliant options. For example, if they are deploying a GDPR-bound service, the dropdown will only show Europe. They will not show US. Similarly, this is the proactive validations, the net safety net. Before anything gets provisioned to the cloud, it checks whether everything is fine or not. If that's not found, the deployment will just fail. So we are not more getting an Instagram from the security team 2 weeks later because a bucket was misconfigured. It's about building the trust into the automated workflow. In the next slide, we're going to show what is the impact. So this is actually a real-world scenario from our team. We had done a project, workspace compliance project, in which we had to do a retrofitting of a lot of data to make the compliance projects, and each binary in other outside world, you can call it microservice. Each microservice took 2 weeks to make it compliant, and we can't keep doing it. And as a TPM, I wanted to get invisible TPM, and how can we stop someone from my team spins up a new service, hey, can you chase that person to make it compliant? I wanted to get out of the loop so that assets are infrastructure born compliant. I don't want to keep cat herding people, hey, can you make it compliant? Can you make it compliant? So how can we avoid this high cost of retrofitting new systems once they reach production? That was a massive compliance tax. And that hits right when you're trying to launch. So our goal is to delete that tax entirely. So how we choose that compliance as a default? So we had a guided templating. So whenever someone goes to spin up a new service, wherever you spin up a new service, we have our own tools where spin up a service. So you get instead of manual complex setup, the developer sees a simple prompt like, are you enabling regionalization? If they say yes, then it gives the isolated EU and US environment and the correct architectural layouts automatically. So basically, we are giving a prompts when you spin up a service, are you enabling regionalization? Yes or no. If you choose yes, the architecture is different. When no, the architecture is totally different. And the next, hardening the defaults. The platform automatically injects the mandatory compliance tracking libraries and necessary configuration directly into the new service manifest. So every service is a manifest file. The manifest file keeps changing based on what workflow you are doing. And the last, pre-provisioning validation. This is the fail-safe. Before the service is even deployed, we have a pre-submit checks. Every organization has some sort of checks before you validate it. So we check if an EU-based shard attempts to talk with the non-EU backend, the pre-submit checks fail. So overall, the impact was clear. The platform guarantees the service is correctly regionalized before it even reaches production. We are completely eliminating the 2-week retrofitting penalty per microservice. Imagine a 20-year product or service, how many microservices would have? And we have a workspace, we have more than 6 products in our portfolio. So we are talking about thousands of microservices in scope. So this shows the immediate and tangible cost saving of shifting the left. Next continuous enforcement, I'll hand off to Bharath to talk about that.
All right. Getting systems to be born compliant at turnup time is a big win. But what about existing compliance systems? We make changes or evolve existing systems quite often, and this can lead to backsliding from the compliance baseline. This could be because of code changes, configuration changes, or even adding new dependencies. To stop this backsliding, we rely on continuous enforcement. Every single time a developer proposes a code or configuration change via a pull or merge request, Our pipeline automatically runs the exact same suite of compliance checks that we use during turn-up time. The system acts as a vigilant guardian. It immediately flags and blocks attempts to introduce non-compliant changes. But we don't just block them, we guide them. These pull request scans provide developers with clear, immediate instructions on exactly what the violation is and how to fix it. It creates a tight loop of iterative correction. The same developer that introduced the violation addresses it, pushes a corrected version, and the code is instantly re-verified. Compliance is achieved before the code is ever merged. Now, why is this good? Compare this to a world where a developer can submit their non-compliant change. An audit tool picks up on this violation much later and creates a ticket or bug for the team. Another developer now on the team might have to get state on what changed, why is this issue happening, and how do I fix it. This is not ideal. Continuous enforcement also has a secondary benefit for our compliance partners. Every check, pass, and fail across the platform is logged as persistent audit proof. It completely replaces the painful process of manual evidence gathering with an automated trail, providing high assurance for our auditors. Now, let's look at a high-level example of how continuous enforcement happens in practice using GitHub Actions and Open Policy Agent as an example. It starts when an engineer opens a pull request to merge a feature branch into the main branch. This automatically executes a GitHub action to run an OPA scan job. The proposed code or infrastructure changes are analyzed against our established machine-readable compliance policies. If there are any failures, the developer receives immediate feedback directly in the PR, and they must push a fix to proceed. Once the developer pushes a fix, the GitHub action runs the scan job again, and only if there are no violations, the merge completes successfully. This workflow ensures that no change that makes a system backslide from its compliance baseline is submitted without the developer first getting a chance to fix it. Next, let's look at integrating compliance checks into our CI/CD pipeline. Integrating compliance checks directly into our CI/CD pipeline ensures continuous enforcement at various stages, including code commit, build, testing, and deployment. There are many types of CI/CD checks depending on what they're targeting. Some examples of them are static analysis checks. They examine the application code itself to detect insecure data handling practices or hard-coded credentials before they're ever committed. Infrastructure as code validation checks. These scan infrastructure as code like Terraform or CloudFormation to ensure configurations strictly meet requirements, such as mandatory encryption settings. The third type are dependency scanning checks. These can help identify any third-party libraries that contain known vulnerabilities or licensing issues being introduced in the system. They can also help identify dependencies that don't meet the requirements for a particular compliance program. The last type here is data governance checks. They verify that data storage and retention practices always adhere to our defined policies. Now, a common concern in adding a lot of CI/CD checks is that it will slow down developer velocity. This is a legitimate concern, especially if we don't have some sort of quality control over the checks we introduce into the system. To address this, we use strategic deployment modes that allow teams to smoothly transition into adding and enabling these checks. New policies can be added in audit-only mode. This is purely observational. Violations are passively recorded for review without actually blocking the deployment pipeline. It is the ideal approach for baseline measurements or of existing systems or when we're introducing new regulations. It gives compliance and security teams precise visibility and scoping of affected systems before moving to strict enforcement. Now, once we are confident that the policy is tuned appropriately and the baseline is understood, we can flip these checks to blocking mode. This halts the CI/CD pipeline upon detecting a policy violation. It provides developers with specific actionable feedback early in their workflow, and this forces the developer to remediate, and only when the policy passes, the change is pushed through. This mode helps to maintain zero drift, meaning non-compliant code or configuration simply never reaches production as long as it's covered by a blocking mode check. This slide is a little bit about exemptions. So what happens if one of these checks has a bug or is broken in some way? Developers can't push code because of a faulty check. It is vital for compliance checks to have a way for developers to file for exemptions. Any check will first verify existing exemptions before surfacing violations to the user. This helps developers to unblock themselves in case the check has a bug or is broken in some way. These exemptions can also be fed into generating audit trail without halting developer progress. In some cases, we have leveraged these exemptions to roll out a check that targets new systems only. So the way this works is we exempt all violations that exist at the time of creation of the check and roll out the check in blocking mode. This helps prevent accumulation of compliance debt while allowing existing violations to be fixed on their own timelines. All right, now that we have covered how shift-left compliance works, let's take a look at the outcomes and challenges of applying it. The effectiveness of shift-left compliance stems from a fundamental change in mindset combined with powerful automation. In our personal experience, it has silently driven long-term efficiency for many teams across our organization. First, now new systems are born compliant, reducing the risk of non-compliant feature launches and helps avoid costly remediation cycles later on. It significantly reduces long-term engineering cost. While there is an initial investment to set up the framework, it distributes compliance into the natural development cycle, preventing massive resource drains in the future. CI/CD integration ensures automated checks act as vigilant guardians, automatically flagging and blocking attempts to introduce non-compliant changes, which helps prevent backsliding. This framework allows for scalability across programs. Adding support for new regulations requires adding new policies within this framework. Now, beyond the architecture, this improves the developer experience. Golden paths and guided configs help reduce the burden on developers when it comes to making the right choices for compliance. Automated feedback reduces the cognitive load on developers, allowing them to fix issues early and enabling faster development cycles. Shift-left compliance helps simplify auditing and evidence generation. Because every pipeline check is automatically logged, we generate immutable proof of enforcement. This drastically reduces manual audit preparation time. Ultimately, this fosters a culture of compliance. This approach helps break down the traditional silos that exist between eng teams, compliance teams, and security teams, encouraging engineers to take ownership of their system's compliance state. Now, to be completely truthful, it is not a magic bullet. There are real limitations and challenges with this framework. Shift-left cannot eliminate the need for re-architecture when new regulations significantly change fundamental properties. Major paradigm shifts in the law will still require major engineering work. If automated validations are poorly tuned and frequently halt the pipeline with false positives, developers will experience alert fatigue, leading to frustration and blocked workflows. The framework does not automatically solve for organizational silos. Success depends on the shift in mindset across engineering, security, and compliance teams. Note that this was mentioned both as a positive outcome and a limitation. This is because our mindset first needs to change before we can experience the benefits that come with it. Finally, implementing this requires a heavy upfront investment in setting up the compliance as code framework and integrating with your platform before long-term savings are realized. The goal of our talk is to sell the idea that if you never pay this cost upfront, you will perpetually live in a reactive scramble for every compliance program you have to deal with in the future. Now, a note about AI. AI is starting to fundamentally change how we do everything. It is no different here, and we wanted to share a note on early areas of benefits we have observed. First, there are context-aware IDE plugins. AI plugins integrated directly into the IDEs can act as real-time compliance coaches. The plugins analyze code as it is being written and can generate suggestions to the developers that ensures their changes are compliant. This ensures compliance standards are met even before a commit is made. Second, AI-generated fixes. Compliance checks do contribute to alert fatigue by just showing violations to the developer. The onus is on the developer to understand the violation, figure out the next steps, and actually push a fix. AI can help go one step further here. Using the violation, it can automatically generate the exact fix for the non-compliant infrastructure. This further reduces the burden on developers for maintaining compliance. And lastly, democratizing policy as code. Historically, authoring and rolling out complex governance policies has a steep learning curve. AI now allows teams to describe their compliance intent in plain English, automatically generating the corresponding deterministic policy code. This reduces the barrier of entry and encourages more use cases to use this methodology. That brings us to the end of our talk. To recap, the traditional approach to compliance, a reactive scramble to meet regulations, is not sustainable for modern engineering teams. Shift-left compliance moves the organization from a reactive to a proactive and scalable engineering paradigm. By integrating compliance requirements directly into the development cycle, our systems are born compliant and stay compliant. Shift-left compliance helps bend the cost curve by replacing large remediation efforts with incremental updates that can be handled within the development lifecycle. And automated CI/CD checks prevent backsliding and enable continuous enforcement. It involves an evolved culture breaking down silos between engineering, security, and compliance teams. Ultimately, by treating requirements as code, compliance transitions from being a painful tax into a strategic enabler of customer trust and organizational success. Thank you for attending our talk, and we have time for questions.